Hello everybody, today we're going to test a claim about a proportion. So let's go ahead and read the problem. We have a study of 1,228 randomly selected medical malpractice lawsuits, and we found that 856 of them were dropped or dismissed. Use a 0.01 significance level to test a claim that most medical malpractice lawsuits are dropped or dismissed. So always, you need to write the claim first. What is the claim? Now, they're saying the claim was most medical malpractice. Whenever you read most or they give you percentage, you know that you are dealing with proportion. Most medical malpractice were dropped. That means more than 50% are dropped. So that means the proportion is greater than 0.5, writing the 50% in decimal form. So this is your claim, okay? Now, you always write the claim first. Also, it might be a good idea also for you to write the information given to you. So we have a sample of 1,228. So N is 1228. And we found from them 856 of them were dropped or dismissed. So X is 856. Okay, from there we're going to get the sample proportion. The sample proportion is p hat, and that's always x over n. We can get that a little bit later on. So here we have the claim, and we're going to test it. They gave me the significance level, so we know what alpha is. The first thing you need to do in all hypothesis testing is always identify the null and the alternative hypothesis. What is the null hypothesis? Well, remember the null will always, the parameter is always equal to the value. There's no change. So P is equal to 0.5. Okay, the null hypothesis, remember, always include the equality. The alternative hypothesis, H1, some people write it H8, either way is fine. The alternative hypothesis would be, in this case, P greater than 0.5. That's your claim, right? And so that's what we have right here, the null hypothesis, the alternative hypothesis, okay? Now, again, we have a right tail test, so this is going to be crucial in finding the critical value. Now we have the null and the alternative hypothesis. We need to identify alpha, the significance level, which is in this case 0.01. We're going to find the test statistic. Remember, the test statistic, we can get it from using either graphing calculator or a StatCrunch. I'm going to do both. I'm going to use the formula, and I'll use a graphing calculator a little bit later on. PQ over N. So this is the test statistic when we test a claim about a proportion. P hat is the sample proportion, there it is, and P hat in this case is X over N. X is 856 over N, which is 1228. This is your P hat, and then if you use your calculator, you should get 0.697. You might have more numbers there. So this is P hat, and we'll plug it in here. So 0.697 minus P. P, you get that from the null hypothesis right here. So it's 0.5 over square root of P. We already know what P is. That's 0.5. Remember that Q is what? It's the complement of P. So 1 minus 0.5 is also 0.5 over N, and in this case 1228. So if you plug this in your calculator, you should get this number. You should get 13.811, and there's going to be more number. I'm going to stop at 2 digits after the decimal point. So 13.81. This is your test statistic. Again, I'm going to show you in a bit how to find it using a graphing calculator. Now, now that we have the test statistic, we can also find the critical value. What is the critical value? Sometimes we have one critical value that's positive, one that's negative, or two, one positive, one negative. In this case, since I have a right tail test, I have one critical value and it's positive, and that is z's of alpha. Okay, that's z's of alpha. In this case, z's of 0.01. So just to give you the graph of how to get, we can get the critical value. So if you recall what this is, the area to the right of the test statistic is 0.01. So here you have it, z of 0.01, and this is the critical region. The area here is 0.01. Okay, which means the area to the left of the critical value would be 1 minus 0.01 or 0.99. Okay. Now, how do we find the critical value? Well, you can find the critical value. I've shown that in previous videos in StatCrunch, but you can also find the critical value easily using the table, the positive z-score. So you want an area that gives you the area to the left. So what do we have in this particular problem? We have the area to the left of the critical value, and that is 0.99, and you are looking for the area. This is the area, if you recall, and this is the z-scores right here. The first column, the first row give you the z-score. You are looking at 0.99. So let me show you where it is. That is right 0.99. This is as close you can have to the critical value, 0.99 right there. You can see that right there, 0.9901. This you can find it in any positive z-score table. 0.9901, that's the closest you can find. You don't have anything closer than that or somewhere in the middle. So that value right here, it should get you z of 2.33. So here's the value. You go back here, it's 2.3 right here, and then you go up, should get you 2.3, and this is 3. So 2.33 is your critical value right here. Okay, so now that we have the critical value, and then we have the test statistic, you notice that the test statistic is 13.81. It's not less than the critical value, it's greater than the critical value. It's right here. It's right here in the critical region. This is your test statistic, is z equals 13.81, and that is in the critical region. Since the test statistic is in the critical region, what do? Since the test, we have to what? We have to reject the null hypothesis, okay? Because the test statistic falls within the critical region. We have to reject the null hypothesis. Remember, any decision you make, you make the decision on the null hypothesis. So we have to reject the null hypothesis. And that is a decision. So we reject the null hypothesis, so we have evidence to support the alternative hypothesis. We have evidence to support that P is greater than 0.5, which is the claim. Okay, so that's what we're gonna go ahead and do here. There is sufficient evidence to support the claim that most medical malpractice lawsuits are dropped or dismissed. Okay, so there is sufficient evidence to support the claim that most medical malpractice lawsuits are dropped or dismissed. That would be the actual wording of the non-technical wording of the decision. So you can write it down. There is sufficient evidence to support the claim that most medical malpractice lawsuits are dropped or dismissed. Okay, so this is the way we can test a claim using the critical value. We're going to go ahead and now use the graphing calculator. Okay, so that's what we're going to be doing now. So let's see, how do we do this? Let's go ahead and do this. The way you can test a claim, you go to stat, that's the first thing you do, then you go to test. Okay, if you notice, what did we do? We use the prop Z test. That's for proportion Z, that's what we have, the Z test. And we are dealing with only one sample, so there it is. That's what you're going to have to look for. Depending on what type of calculator you have, I have number 5, but it depends on your graphing calculator. One prop Z test, if you choose that, they're going to ask you for a values to go ahead enter. And that is the null hypothesis. What is it equal to? It's equal to 0.5. Okay, and you enter 856. I just did them just now, 856 and 1228. These are the values right here. So you enter them, you enter the information, you enter X and you enter N. And then since I have a right tail test, you go to the right tail test. If you have a left tail test, you choose this, or not equal, you choose this. And then you click on calculate. So go ahead and click that, and these are the values that you're gonna get. This is Z, this is your test statistic. There you have it. We got the same value, 13.81, and we have more values after the decimal point. Okay, so this is your the test statistic. If you notice, P right under it is the p-value. And what is the p-value? P-value in here is equal to 1.12926, but don't forget 2926 times, you have here e to the negative 43, so times 10 to the negative 43. Okay, so this is going to be a really small value. You are talking about 0.0000. I mean, we have it. This is going to the left 43 places to the left. So this is the p-value really, and you can continue on, but this is all we really need to make the decision here. So this is your p-value, and the p-value in our example is less than alpha. Alpha, remember, is 0.01, less than alpha. Since the p-value is less than alpha, whenever we have the p-value less than alpha, we reject the null hypothesis. Remember, the decision is always rejecting the null hypothesis. Okay, and we write the decision in non-technical form the same way we did before. So we did this by hand of testing claim about a proportion using critical value and the p-value method. Okay, I hope you found this video helpful. Have a good day, everybody. Bye-bye.